Hello everybody and welcome to Blockchain Expert. In this video, I'll be going over centralized versus decentralized systems and talking about the importance of decentralization in a blockchain system. So let's begin here by talking about what centralized systems are. So just to go through a few examples, things like Google, WhatsApp, Coinbase, the US government, Amazon, central banks or local banks, all of these would be considered centralized systems. Now, it turns out that most of the systems we interact with today are centralized, and really what makes something centralized is that it's controlled by a single entity. Now, this entity could be a business, it could be a company, it could be an individual, it could be a government. It doesn't really matter what it is. If there's one person or one thing that controls whatever system it is that you're interacting with, then that is a centralized system. Now, that's important to understand because anything that is centrally controlled can be, well, manipulated. It can be changed. It can be modified. You can have your access revoked. People can have certain privileges that other people don't. There's not really a notion of fairness when it comes to centralized systems, and to be able to use a centralized system, you need to trust that system. For example, Google. A lot of people use Google because they trust Google. They trust the Google search engine, so they'll go on there, they'll enter their data, they'll give Google their information, and by doing that, whether they notice it or not, they really are putting a significant amount of trust in the organization that runs, for example, the Google search engine. What were to happen if Google were to be hacked? Well, those people would probably lose their trust in that organization and no longer use it. So when you have a central system or a central organization, company, whatever it may be, people, whether realizing it or not, are putting a lot of trust into that system. And really the only reason that system operates is because they are trusted. When you use something like a bank, the only reason you would deposit money there is because you believe that that bank will be able to give you that money back, that they'll be able to store it safely. When you order something on Amazon, again, you trust that that package is actually going to get delivered, or if it doesn't, that they're going to give you a refund, right? When you use something like WhatsApp, you trust that your data is going to be safe and that WhatsApp, or Facebook, I guess, that owns WhatsApp, is not going to sell your data or do anything, malicious with it. So just keep that in mind. Pretty much everything you use on a daily basis, you are giving a significant amount of trust. And in a lot of scenarios, once that trust is broken, you no longer want to use that product or service. Okay, so continuing here, I'll just go through some examples. I already kind of showed them here, but we have Google, governments, local and central banks, we have messaging apps, Amazon, and then exchanges. Now, I'll just touch on exchanges here because this one is one that some people might get a little bit confused by. When we have something like Coinbase, which is a cryptocurrency exchange, this is a central exchange. Even though this seems like a decentralized exchange or something that wouldn't be a central system because it deals with cryptocurrency, Coinbase itself is a company. The people at Coinbase can tell you at any point in time, hey, you no longer have access to your money. Whatever you're storing on our exchange, that's ours now. We're not going to give it back to you. They could do that at any point in time. You must trust Coinbase to use that service. You could be banned on Coinbase. You could not be allowed to use the service. They could charge you different fees than other people. If you're in a specific country, maybe they don't allow you access. Coinbase is a central system. So when you use an exchange, especially a cryptocurrency exchange, just because it deals with something like crypto, which typically is decentralized, that does not mean that that exchange itself is not a central system. So keep that in mind. Just because something has to do with blockchain technology or cryptocurrencies, it doesn't automatically make that a decentralized system. There's kind of other properties of the system that need to be true for it to be decentralized. All right, so now that we have a basic kind of primer on centralized systems, and hopefully you realize that most of what you're using on an everyday basis is central, let's talk about decentralization or decentralized systems. So decentralization. The way to kind of visualize this or understand this is to look at the photo I have on the screen here. On the left-hand side, we have a centralized system. On the right-hand side, we have a decentralized system. Now, a centralized system is where everything goes through essentially one node or one kind of main object. So in this case, we have a basic graph, and all of the different, we'll call them nodes here, are pointed towards that one central node. Now, that would be your central system, and that could be a database, that could be a server, that could be a website, whatever it may be. The point is that there's one thing here. That's it. Just one single point, and whoever controls that point or controls that node pretty much has control over the entire system. Whereas you go over to the right-hand side of the screen and you look at the decentralized system, here you can see that there is multiple nodes. So we would have 4 kind of orange nodes here, yellow nodes that are being highlighted, and then the rest of the nodes that are connected to that would be kind of participants in the network, or they'd be maybe using those nodes. Now in this scenario here, one person does not have complete control over the network, or one node does not have control. If a node were to go down, if a node were to be hacked, if it were to act maliciously, you could go and use a different node because there's multiple ones on the network. It is decentralized. It is distributed across, in this case, multiple nodes. And again, when I say nodes here, I'm really just talking about the little dots. If you're not familiar with graph theory, no problem. We'll go through kind of all of the terminology you need to understand later on if we get to that point. So let's just go through kind of the, I guess, formal definition of decentralization, which is right here. So decentralization is the process by which activities of an organization, particularly those regarding planning and decision-making, are distributed or delegated away from a central, authoritative location or group. So again, this image kind of clarifies this pretty well. On the left-hand side, we see our centralized system. We have one place where everything is kind of being done, all of the decisions are being made, etc. That has complete control. Whereas we move over to the decentralized system, and now we have 4 places. We've expanded that, we've delegated it out. That really is what is meant by decentralization. So continuing here, decentralized systems allow for trustless interactions. So this goes with what I was saying before in the kind of centralized system section, where when you use a central system where there's just one person or one entity controlling it, you must trust that entity. Now, when you go to a decentralized system, what happens is you no longer need to trust a single person, a single organization, a single entity. What you do instead is you trust the network, which is made up of many different entities, many different companies, many different people, and the algorithms and kind of cryptography and all the other stuff that would go into networks like blockchains make it so you really don't need to give any trust to a single person, to a single organization. Instead, you trust that the math and the theory behind this blockchain technology is correct and accurate, and that allows you to use the network with, a relatively low degree of trust required. Hopefully that makes a bit of sense. Of course, at this point, you may say, well, if there's a bunch of people on the network, doesn't that mean I need to trust all of them? That's a fair question, but due to the way that blockchain technology works, that's not really the case. And there's all kinds of consensus algorithms and advanced mathematics that go into allowing you to not really have to trust anyone and to just trust that the network as a whole is going to work. So I know that might be a little bit confusing, but for now, you can kind of imagine that decentralized systems really remove this burden of trust and allow you to use something without being worried about malicious actors or some central body kind of controlling what it is that you're doing with the system. All right, so let's move over here and just kind of look at this image a little bit larger just to go through this again. When we have our centralized system, we have kind of this central node. There could be multiple nodes in the middle as well, but they're all controlled by the same entity, person, company, whatever it may be. Whereas on the right-hand side of our screen, we have our decentralized system. We have multiple nodes. If one node were to go down, if one node were to be acting maliciously, that's fine. We just move over and use a different node. I don't need to use the same node every single time. I don't need to trust one person or the owner of that individual node. I just trust the network as a whole because it has a ton of different nodes on it. All right, so let's move now and talk about some advantages and disadvantages of decentralization. Now, decentralization seems like a great thing, and it is one of the main kind of selling points of blockchain technology is that it is typically decentralized, and that means you don't have to trust that main entity. And I'm going to keep saying that because it's very, very important. Now, the issue is with this distributed and decentralized technology, it becomes very complicated to implement, and there is actually quite a few disadvantages that many of you, if you've ever tried to, say, trade crypto or send crypto around, are probably familiar with. So let's just go through this table here and talk about some differences here with centralized and decentralized systems. So in a centralized system, you typically have a low network diameter. That means everything's close together, and this allows for the fast flow of data. So what I mean by network diameter is that when you think back to that image there, we had one central node, kind of the origin where all of our data was coming in, and then all of our data would be coming out of there as well. So that means it's very easy, it's very simple, and it's just much faster to flow data with that type of architecture or structure because everything's going into one place, everything's coming out of one place. It just makes things very, very quick. Now, in a decentralized system, you have a much larger network diameter. You can have participants that are spread out by many different edges, and this means that flowing data throughout the network can be much slower. slower. It needs to propagate into many different places, and it can just have a longer path to kind of get to its destination. So second thing here, with a centralized system, it's usually much easier to implement this system. So think from an engineering perspective, actually creating it, and that means that it's usually much more highly performant. Continuing with a decentralized system, this is very difficult to implement, and it also has lower throughput, which causes lower performance. So think about any blockchain network you may have interacted with before, maybe something like Bitcoin, Ethereum. Usually these are actually quite slow if you compared it to just say sending a message, right? Like if I wanted to send you a chat message, it can take, many minutes, sometimes hours to actually have a transaction go through. There's many different reasons for that. It's not just because of the difficulty of implementation, but with decentralized systems, it's just a much more complicated engineering problem. Usually they have lower throughput, and it just means that you're going to have lower performance. Whereas with a centralized system, if I can have one central server or one central location where everything is happening, it just allows me to do things much easier and typically to have higher performance. Continuing here, when we have a centralized system, our data conflicts are usually easily solved and synchronization is easy and clear. Whereas in a decentralized system, a complex protocol is needed to dispute data conflicts and to find a resolution, and synchronization is typically very difficult. So think about in a centralized system how easy it would be to determine if there is a data conflict and then to solve that conflict. You have one main place, all of your data is there, all of it's coming in at predictable time increments, etc. And it's easy for you to synchronize the different data and to solve any conflicts. Like if you have two versions of the same thing in a central system, you can say, okay, I'm going to pick this one over that one. You just write some code, for example, that would do that, right? Whereas in a decentralized system, it's much more difficult to do that. Since you don't have kind of a single source of truth here, you have many different nodes across the network. There's no easy way to say, okay, I'm going to trust this node, but I'm not going to trust this node. Or this node sending me this data, I'm getting different data from this node. Which one do I pick? You can't just choose which one based on a predefined kind of algorithm. Well, you can in a way, but that algorithm is much, much more complicated than in a centralized system. So hence why a complex protocol is needed, and why it can be difficult to resolve conflicting data and to synchronize that data across the entire network. Continuing here, in a centralized system, you have a single point of failure. It's easy to take down, it's easy to go offline. For example, think about the Rogers example I was talking about in the previous video. One little mistake, they're upgrading the system, and all of a sudden, half of the country of Canada's internet is just down for an entire day. Whereas in a decentralized system, you don't have this same problem. A network can still function if a large portion of the participants are taken down or go offline. So even if a bunch of the nodes go offline, a bunch of the nodes aren't acting properly, maybe they're being malicious, they're not submitting the right data, for example, that's fine. The system will still operate because of the nature of a decentralized system. All right, continuing here. So a centralized system has a central authority that can censor, change, or delete data. We've kind of already talked about this before. And then in a decentralized system, censorship is much harder, and it's almost impossible to change or delete existing data. All right, next, in a centralized system, participation is regulated by a central authority. This means someone can tell you, yes, you're allowed to participate. No, you're not allowed to participate. You must pay me this much. You must do etc. if you want to be a part of the system. Whereas in a decentralized system, theoretically, anyone can participate in the network, and there are no gatekeepers. Now, I should put an asterisk here because in some decentralized system, there is a monetary gatekeeper or monetary, barrier to entry, where you need to have a certain amount of money or a certain amount of a specific currency to be able to participate in the system. However, it doesn't matter who has that money. It doesn't matter where you're from. There's no individual bias. It's just strictly a requirement to join, and that is financial. So, of course, that is kind of an asterisk here. Not everyone can participate in decentralized systems if they don't have the financial means to do so, but there is many decentralized systems in which there isn't a financial barrier to entry. So just wanted to add that in there because, again, there is some blockchain networks where if you wanted to, say, be a validator, you would need to put up a certain amount of the kind of native currency, which we'll talk about in a future video. All right, so with that said, I think that's going to wrap up this video here on decentralization. Really, I just wanted to kind of ingrain in your brains the difference between centralized versus decentralized systems and the advantages and disadvantages of each. In many scenarios, it does not make sense to try to make something decentralized unless we're going for a trustless interaction with that system. Now, that is why blockchain is very popular, especially in a lot of places in the world where you cannot trust a central authority. However, in a lot of scenarios, if you're making a website, if you're making your own application, there's really no need to do that in a decentralized manner unless you really need to make sure that everyone interacting with the system trusts it no matter what. So just as a key takeaway here, typically blockchain networks are decentralized. That allows trustless interactions with the network, and that's one of the main benefits of blockchain is that you don't need to trust a central authority or entity when using the system. You just know that everything is going to be safe and secure based on the protocol and the mathematics and the way that the blockchain network operates. So with that said, I'm going to wrap it up here. I hope you found this valuable, and I look forward to seeing you in another Blockchain Expert video.